So if you walk into a store right now, you can buy an HDMI cable for like $10. It's totally an afterthought.
Yeah, completely. Just grab one off the shelf and you're good.
Right. But today, we're taking a deep dive into an HDMI cable that costs $685.
Which is quite the jump.
Yeah, no, it sounds crazy. So to understand why anyone would pay that much for the DVI 2550 AOC, we pulled a stack of engineering spec sheets and professional AV installation guides.
Basically, our mission here is to explore this invisible light-bending infrastructure that's holding the high-end audiovisual world together.
Exactly.
Because that $685 sticker shock actually makes perfect sense once you look at the physical nightmare of moving high-quality data over long distances. I mean, we hit a very hard wall with standard copper wires.
It's just a strict electrical limitation. We are talking about moving 18 gigabits per second of 4K video. It's like trying to blast a fire hose of water through a mile-long garden hose.
Right, the pressure just drops.
Yeah, exactly. If you try to push that many electrical pulses down, say, 160 feet of standard copper, the physical resistance of the metal essentially blurs the signal.
It loses all its fidelity.
Right, and by the time it reaches the display, the zeros and ones look like a smeared painting, and your picture just drops out entirely.
And in a professional environment like a massive auditorium or a live broadcast, a smeared signal is a complete catastrophe.
Oh, for sure. You'd lose your job.
Definitely. You need flawless 4K video traveling up to 328 feet, or about 100 meters, without a single dropped pixel.
Right.
The spec sheets we looked at demand 8-bit 4.4.4 or 10-bit 4.2.2 color depth.
Which is a lot of jargon, but
Yeah, that jargon basically just means the system is sending full uncompressed color information for every single individual pixel on the screen. There are no data shortcuts at all.
and you have to add in the continuous live HDCP security handshakes too.
Right, those are constantly verifying the connection. So copper simply cannot carry that immense data load that far without electromagnetic interference just completely ruining the picture. So because copper physically smears the signal, we're forced to completely change the medium. We aren't sending electricity to carry the video anymore.
Exactly. We shift to AOC, or Active Optical Cable technology.
Okay, what does that mean exactly?
Well, inside this completely standard-looking HDMI cord are 4 polyfluorinated optical fibers. They take that heavy video data and transmit it using pulses of light from 850 nanometer lasers.
Wait, actual lasers?
Yep, actual lasers. Then, running right alongside those lasers, are 6 traditional copper wires that handle the lighter two-way communication between the devices.
Okay, hold on. Wait, you just said there are optical glass or plastic fibers inside this thing?
I did, yeah.
Commercial installers are going to be yanking this blindly through like 100 feet of drywall and ceiling grids, glass snaps. Fiber optic threads are notoriously delicate.
They usually are, yeah.
So how does this cable not just shatter inside the wall?
Well, that polyfluorinated material I mentioned is the secret. It is a highly specialized polymer that allows the internal fibers to bend at a tiny 2-millimeter radius.
2 millimeters. Wow.
Yeah, you can basically fold this cable around a sharp corner, and the material ensures the laser light keeps bouncing perfectly down the core without escaping or snapping the thread.
But even if it bends, it still has to survive being pulled and stepped on during construction. I mean, the engineering docs list crush resistance at over 500 newtons.
Which is massive.
Right, and pulling force at 200 newtons. So in real-world terms, that means you could stand a heavy adult directly on this optical cable and it wouldn't care.
Not at all.
And an installer can just put their back into yanking it through a tight conduit without breaking the internal fibers.
Oh, it is built like an absolute tank.
Yeah.
It also features a plenum-rated jacket.
So that means it's fire safe, right?
Exactly. The outer casing is legally compliant to run directly through a building's air circulation ductwork. But honestly, the engineering detail that really solves the physical installation nightmare is the detachable docking connector.
Because getting a massive, chunky HDMI plug through a narrow drill hole in a wall is usually impossible.
It is the worst. So instead of drilling a huge hole, you just unclip the main plug, you snake the tiny microconnector through those tight wall spaces, and once it is through, you reattach the full-sized HDMI docking plug at the end using these built-in locking pins.
That's super smart.
It really is. And what's even more brilliant is that translating all this video into lasers requires no bulky external power supply.
Wait, really? It doesn't need to be plugged into the wall.
Nope. The internal chips draw less than 0.235 watts. They pull that tiny sip of power directly from the TV or computer it is plugged into.
That is just incredible. So the next time you are sitting in a massive stadium or a conference center and you see a pristine 4K display on the far wall, you will know to appreciate the invisible $685 light-bending infrastructure making it possible.
Yeah, it really highlights the physical limits of our digital world. We are already at a point where we have to translate our video signals into actual lasers just to get them from one side of a building to the other.
Which leaves you with this to think about. As our everyday data needs keep skyrocketing, what happens to our physical infrastructure when we inevitably outgrow the capacity of even these laser hybrid cables?